Good afternoon, Assembly Room. I am delighted to welcome Mac Chapman, who is going to talk about making your code really boring, which is, I hope, interesting. So, big welcome to Mac.
Okay, hi folks. I'm really excited that so many of you are here to come and hear about really boring things. So, my name's Mac. I'm a senior developer at VirtualStock. I've been developing software professionally for over 10 years now, and I've made a lot of mistakes. And a lot of those mistakes were down to me trying to be a little bit too clever, do something a little bit too exciting, when I should have been keeping things really simple. So here's a few of my techniques that I've learned the hard way for making things nice and boring. So this talk has its roots in a lot of other people's work. I've referenced them wherever I can. If you're interested in following any of them up, check out the slides. They're on the Slack. They'll be on PyCon's website later. They're on my Twitter feed. Everything's linked, so you can click through. So here's my case in a nutshell for boring code. You have enough problems already. They've all come from your customers, your requirements, your contractual obligations, and those problems are worth money to you. So try not to make any more along the way. Out of the tar pit describes these kinds of problems as accidental complexity as opposed to essential complexity. So how do we avoid accidental complexity? Well, I've taken an analytical knife to our aims and divided them up here. So in reality, I think these things overlap a lot, but it's interesting to talk about them separately. So for this talk, I'm going to be talking about making things predictable. So before I do a thing, I should basically know what's going to happen, and manageable. So as I work in the project, I should be able to fit everything I need inside my head. These interact quite well. If something's predictable, it can probably leave your head, which makes everything a little bit more manageable. Dan North talks about software that fits in your head. I like that as a concept. So first up, let's talk about predictability. Before I do a thing, I should more or less know what's going to happen. We're really talking about usability here. If you imagine that you are a designer working on an interface, you're trying to make it really easy to use. And you're doing the same thing when you're coding. Every line of code is a user interface. So you need to think about your audience and cater to them. So this Philip Pullman quote explains what I'm talking about really well. He's talking about prose, but I think it really applies. I'm going to read it out in case anyone don't know how well people can see the slides. So he says, "This is partly a matter of taste, but a limpid clarity is a great virtue. If you get that right, the story you tell will not seem to anyone as if it's intended for someone else. No one is shut out. There are no special codes you have to master before you can follow what's going on. Of course, this sort of thing has been said many times before. W.H. Auden and George Orwell both compared good prose to a clear window pane, something we look through, not at." Which naturally brings me to the next question. What are you inviting your audience to look at through the window of your telling? What are you showing them? Your code should be a window into the problems you're trying to solve. Let people look through your code onto the subject matter. Don't let your code be the thing that they're trying to decipher. So how do we do that? How do we make things predictable? If there's one thing you take away from this talk, if there's one thing you remember, I'd like it to be this concept: the principle of least astonishment. What I love about it is it follows its own principles. You already know what it means. It means that your users should not be surprised by what your interface does. Now, there's a caveat here that I think is really important. Ruby is one of my favorite programming languages, and it is designed according to the principle of least astonishment. And people who start learning Ruby find this quite surprising because they find it unpredictable. And when asked about it, the creator of Ruby, Matt, had this to say. He said, "The principle of least surprise means principle of least my surprise. And it means the principle of least surprise after you learn Ruby very well. So they're not quite talking about making things easy to learn or easy for beginners here. We're talking about thinking about your audience. He's thinking about consistency and conventions. And you might think this clashes a little bit with the Pullman quote from earlier, but I don't think it does. They're both talking about your audience and working for what they need you to express. So as a writer, Pullman writes in English. As a developer, you write code for people who already know how to read some code. Think about your audience and think about what they need. And think about this as you write every single line. So let's take some examples. So naming things. Names, how we tell our audience what things do. People say it's one of the hardest things in computing, and I tend to agree. So I've got 2 real-world examples that I want to work through, and we'll talk about how we can improve them. So first up, these CSS classes. These are real. I found these in a code base. So we've got 3 classes here. They're called green and red and yellow, and the green one, it makes things green, and the red one, it makes things green, and the yellow one, for anyone who doesn't read hex, that makes things black. And black is not yellow. But this goes a bit deeper than this. It's not just the color. What do these do? What are they for? We don't really know, because this is an abstract bit of code, but what's the intention? What did the person who wrote these classes intend for us to do with them? So let's make some assumptions and improve things. They operate on a table cell within a row, and they change the text of that row to be a certain color. So let's say row in the name. We can now give our user a hint as to what they're going to be used for. And I don't know the intended usage, as I say, but let's add it. Let's call one of them success, and one of them failure, or one of them warning. And I've used BEM here. There are many standards of how you should name your CSS classes. I'm just using an example. What we've done is given 2 hints as to how this might be used. We have separated the intention from the implementation. If the design changes, if we don't want our success to be green anymore, we can change this, and the class name is still valid. So there's one other example I want to talk through, and that's a variable called noecho that existed in a previous project. And the way noecho worked was like this. You sent a command to a device, usually over SSH, and it would return you some data. Now, if noecho was set to true, you would receive the data. And if noecho was set to false, you would not receive the data. Now, some of you have worked out what's wrong there. Some of you are still scratching your heads because the double negative throws your logic circuits off straight away. It's the wrong way round. So how can we improve this? Lose the no. Make a variable called echo. If you handle a positive case, your variables are that much simpler and easier to understand. Programming languages have logic in them. We don't need to add logic to our names. When you get down to something like that, a variable called echo that controls whether or not a function returns something, you might be able to guess what we did with it. We deleted it. Because now we're down to control flow. If you don't want the results of a function, you just don't use them in your software. One less thing to think about. So noecho was gone, lost to Git history. But it wasn't that simple. It wasn't over for us. You see, noecho was actually part of an API we provided to customers. And the API wasn't versioned. Oh no, why didn't we do that? It turned out it's sort of okay. The way it worked was we provided a way to write XML that would effectively be code, and it would run parts of our API. We didn't have a solid schema that we required the XML to adhere to, which was a mistake. We should have done it that. We were young and naive. But we were stuck. You see, our code didn't fail if you put the noecho variable in, and our users would think that it was still there. So they would receive no data from a device. They would think, oh, maybe I need to add noecho. And they would then realize that it was some other problem, and noecho would stay there. And it was everywhere. We could never get rid of this variable. It was very expensive to add versioning to this, so we were kind of stuck. And this is this anti-pattern that can happen whenever you've got a method that can take arbitrary variables or anywhere doubt can creep in. A great example is the Django settings file. Who knows if a setting is still in use in there, if you spelt it right? And there are a load of language features which can help you out with this. So let's fix it. This is the pattern. I see this a lot in code bases. So you've got something in KW args, in your keyword args, and it happens for two reasons. Either you don't know what's being passed into the function, so you just allow anything, or you've got too many arguments and you think it'd be better if we just put them all in a dictionary. And I understand that, but you know this function is 200 lines long, and this is peppered throughout it. So how do we fix it? Easiest thing we can do is make it an explicit argument. But this actually subtly changes the behavior, doesn't it? Because now it could be your first argument, and different things could happen in the function. But with Python 3, we can add keyword-only arguments. So we can put it there, and we've got exactly the same behavior now. We've made an explicit argument, but it can only exist in keywords. And because we're on Python 3, now we can use type hints, and we can tell the user that it should be a Boolean. And we can even add a docstring in there and explain a little bit about it. And so we've gone from giving our future code reader a complete mystery that doesn't mean anything to giving them automatic documentation in their text editor. That's brilliant. So let your function signatures work for you. Use these language features like explicit arguments, type hints, and docstrings to remove myths. Because if you don't, someone will build on your myths. Someone will document them. In summary, just make it really hard to do the wrong thing rather than relying on people to know how to do the right thing. So documentation is talked about a lot. There's a whole conference for it that I've linked here. But it goes a long way towards making things more predictable, so I want to mention it. And there's a lot that's been said, but here are my few tips for making quite a confusing project a little bit more boring. One, have a quick setup guide. I know you should be able to make a build in one step. I know that. But not all projects are there yet. So write down every single thing you have to do to get a working build. Once you've got that list, you can work on automating it. And then make it impossible for the same question to be asked twice. When someone asks you a question, ask them where they've already looked for the answer. Decide where the answer should be together, and then write it. Now, there's a quote that always sticks in my head whenever I think about documentation. It's this one. The only interesting answers are those which destroy the questions. I love this. So if you can answer the question, write down the answer, no one ever has to ask it again, that's great. But the interesting answer, if you can change the code so that the question would never have to be asked in the first place, that's the best one. So you can use your documentation and these answers you write as a springboard to make the changes you need to find that really boring place where no one ever has to ask you anything. When I started at VirtualStock, we had a whole file full of notes as our README, but it didn't really help you get set up, and it didn't really explain much. So I wrote down everything I needed to do to get my first build system working. And then I iterated on it. I changed scripts, I edited things, I added automated bits, and slowly we iterated on it, and we shrunk it down. And when someone else joined, I asked them to do the same. And now everyone gets up and running in no time. And the best thing we've done is iterate on our docs. They're not always perfect, and not everything we commit to them is perfect. But we make notes, we find facts and record them, and slowly we build up something that makes a lot of sense. It doesn't matter if it's not perfect right now. You're just building the first draft. So that's the first half. That's making things predictable. How do we make things more manageable? So what I'm talking about here is working on a code base day by day without struggling. First up, conventions and frameworks. If you use a convention or a framework that's well established, your developers can forget things. If you know that something basically fits into a standard, you can forget about the standard and focus on the problem at hand. So let's take Django as an example. Anyone who comes onto your project knows they can probably run manage migrate, manage run server, and it'll more or less work. And as a project owner, you should make sure that continues to work. That way, anyone who knows Django, who starts on your project, has a load of free documentation that you didn't have to write. And anyone who doesn't gets free onboarding. They can just follow the Django tutorial, and they're 80% of the way to understanding how your code base works. Thank you to anyone who's contributed to that. It's absolutely brilliant. So these things give you a common vocabulary for your team to work on. And if you don't use them, you'll end up writing your own. My only advice to you if you end up there is to try your best to keep it simple, and good luck. A huge mistake I made was when I was trying to write a way of defining mobile phone plans. And I had this idea that I want to make this editable by non-technical people. So I wrote a domain-specific language for it. And I learned a few things there. I learned that domain-specific languages are languages. And languages are really hard to write. You have to be really clever to write a language. And I'm not very clever. I'm definitely not clever enough for that. So I made a horrible, horrible thing. I overrode loads of Python's operators. So you could add a bundle to a mobile phone plan, even though there were two different classes. And none of it made any sense under the hood. It looked good up front, but if you had to maintain it, you were stuck. And so what I learned from that is that readability counts, and beautiful is better than ugly. But simple is better than complex. And if something is ugly behind the scenes, it's ugly. The readability of the entire stack matters. What I should have done is made objects and put methods on them and made lists of things. It should have all been very standard and boring. Here's my lesson there. Don't redefine language features. They're good enough. So this is a pattern that I keep seeing with redefining language features. So you've got a base class of some kind, and you call a method unconditionally in your initialization method, assuming that your subclasses will override it. They can just override your initialization method. You don't need to write a whole new language feature. So a man named Gary Bernhardt wrote a talk called Boundaries, and I think it's absolutely fantastic. I think you should all watch it. I don't have time to go over it here, but I couldn't not mention it in a talk about making things more boring. In practice, boundaries are a game of limiting how far data travels and how far you reach into objects and methods and modules. And you should try and separate your network and database access from your business logic as much as possible, so you can test the business logic in isolation, not worry about where the data comes from or where it goes. I had this really cool idea for this slide where I was going to say, treat your scary code like a nuclear reactor. And I read up on how nuclear reactors worked, and it didn't really make any sense. So it's been that. Here's a better analogy. Treat your scary code like a broken nuclear reactor. Big concrete sarcophagus around the outside, as little in and out as possible. You can unit test everything in the middle and then make it better over time. And finally, testing. Now, a lot of people talk about testing. You might have heard about it. It's pretty good. I recommend it. But I'm going to talk about a bit of testing that I don't hear a lot about. Make it easy to run your code for real like a user would. It sounds really, really obvious, but the number of times I see people not actually run code because they've run the tests is huge. So, and what you'll find is that as apps get more complex, it starts to become harder and harder to run things like a user would run them. Do you have some kind of CSV importing function that needs a particular kind of CSV? Provide it. Put it with the code. Do you need a particular database setup to get to places on your website? Include it as fixtures or factories. How hard is it to hit your shopping cart? I mean, you probably need a product and a user. Is it easy for a developer to set those up? It should be. It should be really easy. So, in summary, make your code predictable by naming things well, using the intention and not the implementation. Eliminate the possibility of myths using basic compiler and built-in language functions. Build your documentation bit by answering questions. And make your code manageable. Use existing conventions and frameworks. Build boundaries, separating your logic from your inputs and outputs. And make your code not just easy to test, but easy to run as well. These are my contact details if you want to chat. Thank you very much.
Thanks, Mac. We've got time for a few questions, if anybody has any. There are no questions. Oh, hello.
So say I've inherited a big, complicated, horrible mess that's really exciting. Do you have any advice on how to start simplifying it?
My first step would be to find the facts and record them. Just every time you figure out a tiny thing about the code base, just get it committed somehow. It doesn't matter if it's like just a comment beside one method that says, I think it does this, I don't know. Because you'll put that in as a pull request, and one of your other developers will go, oh, I did that yesterday, it works like this, and you can work together and just start building things. There are books that I haven't read on working with legacy code. Probably read those.
Any more?
There's one up here.
Ah.
Don't worry, you can just pass it straight to me after. Yeah, I was interested by you making the assertion you should separate data input and output from the code, which kind of flies in the face of things like Link in .NET and many other frameworks that we have now that try and drop the impedance between code and data storage. So I was wondering what you're thinking behind that somewhat counter-fashionable attitude or approach of yours would be.
It really comes down to the testability of a thing. If you can easily test a piece of code with your data access in it, then that's great. But you'll very quickly find that if you've got a piece of code that relies on an API, for example, it's going to be hard to test. If you've got a piece of code that needs to pull 20 objects from the database, it's going to start getting slow to test. So it definitely doesn't work for every part of everything, but it's something you can think about when you're looking at some particularly hairy logic.
Thank you. Any more? Yeah.
Thanks. You were talking about that we are not supposed to override the language and like data methods in Python, for example. But how do you generally think about object-oriented approach of development? Because I know that a lot of people from the community think that it's supposed to die.
I lean towards the functional style of things. I generally think it's easier to test and manage over time. But there are loads of good applications for object orientation. There's no one answer to that.
Got time for just one more, I think.
How do you generally handle when your code depends on different APIs and different partitioned microservices, which generally aren't that good, and refactoring them all at once?
Well, I handle that badly. I don't have a great answer for that. It comes down so much to where I'm working. I mean, if you can be strict about the data that you're expecting to receive and try and only change one contract at once there, then you'll have an easier time of things. But it's easier said than done, I'm afraid.
Thank you very much. I know I've come across code with a lot of these problems in the past. Thank you very much. Big hand for Mac.
Cheers.